Alright, in the previous section we looked at finding a known area for reported z-score and thus the probability associated with that area. And now we're going to look at solving the problem in the reverse. So how do we know the probability for a particular area and then determine what the corresponding z-score would be? Now this is very important because when you're working with large data, and you want to be able to apply it, let's say I want to pull individuals that are the top 25% on a particular scale. What I'm going to need to know is what is the z-score I'm looking for, right? So I'm going to take all individuals that have a z-score lower than a certain amount. That's what I'm going to pull and use. So when you have a particular percentage that you know you want to work with, then in order to be able to extrapolate that from your larger population, you need to know what the corresponding z-score is going to be. So we're going to use this with an example, number 37 on page 251. So here we have, again, we still have our same situation with a bone density test. We still have the same distribution with a mean equal to 0 and a standard deviation equal to 1. And we want to find the P90, which is the 90th percentile. So this is a bone density score that separates the bottom 90% from the top 10%. So the first thing we're going to want to do is write this in probability notation. So we're going to be looking at this in terms of being P, the probability of Z being less than alpha equaling 90. So that's what we're looking at. So our alpha is going to be what we're going to be solving for because we're trying to find what is our corresponding Z-score. But here we already have our probability of 0.90. So if we have 0.90 as our probability, then if we go look on our z-distribution table, and I'm sorry, apologize, this is a little blurry, it's the best image I have right now. If you go and you look on that, and you look in the body of the z-distribution table, and you find the value that's closest to 0.90, and in this case it's 0.8997, so that's going to be the one that's closest. So you see we've got 2 there, it's right in the middle of those two. 0.8997 is the one it's closer to, so we're going to go with that one. So we're then going to follow that across the row, across the row, and we get 1.2 for our z-score for the first two parts of our z-score, and then we go up and see 0.08 for in that row. So when we put that together, our corresponding z-score is going to be 1.28, and you'd write it in the statistical notation like this. So the probability of z less than 1.28 equals 0.90. So keep in mind when you're working with this, remember the z-scores go on the outside of the z-distribution table. The probabilities and their corresponding area go within the body of the z-distribution table. So you can either have a z-score and solve inward into the body to locate the probability and its associated area, or you can have a probability and its associated area and work your way out to find the corresponding z-score. Now, a couple of cautions when you're looking here. First of all, notice special cases of 0.05 and 0.95. You have small charts for these at the bottom of your table. They're very specific amounts, so you want to be sure you use those. And also, you need to check the direction of the question and the table. So this problem is a less than, so the table score is sufficient. Keep in mind, of course, if you were looking at a greater than, once again, you would have to be applying the algebraic of 1 minus, okay? So you'd be subtracting it from the 1.